Alright then, let's move on to complicated cases. The cases in which it'll be slightly tough to calculate the percentage, the fraction, converting the fractional equivalent into the percentage form. And because the fraction will not come down into our the connection chart. The connection chart is up to 1 by 20. So there are some cases in which the fraction, the denominator of the fraction crosses 20. So we'll see those kind of cases in this one. So very simple 4 steps are involved over here in which we have to follow the modus operandi. The 4 steps are, the first step is we have to reduce the fraction to its simplest form. Whatever the fraction is, we have to reduce the fraction to its simplest form if any cancellations are possible. Then the most importantly, we'll find out the 2 consecutive multiples of 5% of the denominator between which the numerator is going to lie. Now, don't worry about the statement if you're not able to get it. I'll just elaborate it properly once we take the examples. But for now, you have to remember that you have to find out, the second step is to finding out the consecutive multiples of 5% of the denominator between which the numerator is going to lie. Now, once we've done that, we'll move on to using 1%. And then third step is to close down on the numerator by using the 1% part. And while doing these 3 steps, we'll follow one particular condition that we have to work in comfortable kind of percentages. The percentages which are 10%, 1%, 50%, 5%, and of course 100%. So let's see how we exactly are going to do that. Let's take an example. Let's say we have to find out 260 is exactly what percentage of 1700. Now, textbook style wise, we used to write it like this: 260 by 1700 into 100. Now, next step we generally used to do is to cancel out these 2 zeros, isn't it? And reduce it to 26 by 170 multiplied by 100. 0 is cancelled out over here to make it 260 by 17, which still is a very uncomfortable format to work in. So this method is a strict no-no from my side. Instead, we'll focus on this fraction 26 upon 170. We'll follow the first step, which is reducing the fraction to its lowest form, which is 13 by 85 by just cancelling the numerator and denominator by 2. This is 2 13s and 2 85s. So the first step is done. I reduce the fraction to its simplest form. It can't be reduced any further. Now, I'll tell you the trick now, what exactly we're doing, why we are actually calculating the 2 consecutive multiples of 5%. What we're doing is, instead of calculating 13%, or rather 13 is what percentage of 85, we are calculating what percentage of 85 will narrow down to 13, or what percentage of 85 will become closest, very, very close to 13 or equal to 13. So we are not actually calculating 13 is what percentage of 85. We're calculating what percentage of 85 is narrowing down to 13. There is a big difference over here, which we'll be able to understand once we see the method over here. Now, so we are finding out 13 will be what percentage of 85 by calculating various percentages of 85 and narrowing down the result to 13. Now, 10% of this number is 8.5. 8.5 is 10% of 85, isn't it? So I'll just write it down. 8.5 is 10%. Now, if I double 8.5, that is double 10%, I'll move on to 20%, isn't it? Which will be double of 8.5 as 17. Now, 13 is definitely less than 17 over here. So I can easily see that 13 will lie between 10% and 20% of the number, isn't it? Now, but we have to move on to the 2 consecutive multiples of 5. So next step, what I'll do is I'll calculate the 5%. 10% I've already got 8.5. I'll calculate 5% as 4.25 by just dividing 8.5 by 2 as 4.25. I'll add them up to get 15% of 85. Now this will come out to be 12.75. Now 12.75 is very close to 13, but still not 13. So I can say that 13 will be greater than 15%. Few seconds ago, we just realized that 13 will be less than 20% of 85. So now I've figured out that 13 lies between 15 and 20% of 85. Now I'll start using 1%. Although I have just narrowed down to the answer very closely because 12.75 is very close to 13, but still I have to move on to the precise answer. Let's calculate 1%, rather let's see what is 1%. 1% is 2 decimal to the left, which is 0.85. Now, 1/3 of which, how did I get to 1/3? Because I'm good at tables and I know that 1/3 of 85 will be 28 because 28 multiplied by 3 will be 84. So I just used 1/3 over here. This is where how comfortable you are in numbers will be checked. Now, if I do 1/3 of 1%, which is 0.33 percentage, I'll obtain 0.28. So if I add 0.28 to 12.75, I'll reach just above 13. And if I add 0.33 to 15, I'll reach to 15.33 percentage. But adding 0.33 percentage, which is 0.28, will take a result just greater than 13. So I shall not add 0.33 to 15 percentage. Instead, I'll just add a slightly smaller percentage and will approximate it to 0.3. So if I add 0.3 percentage, this 12.75 shall get up to 13. Now this is something which is intangible and incoherent. We have to understand this, right? 1% was 0.85, 1/3 of which will be 0.33, which came out to be 0.28. If I add 0.28 to 12.75, it will cross 13. So I'll add slightly lesser than 0.28, which is 0.25. And this percentage will come slightly down, let's say up to 0.3. At this moment, preciseness won't be that much required because we have actually narrowed down to the last percentage point. So my answer over here will come out to be 15.3 percentage. And this is very, very close to the actual answer. You can actually check it by calculator. Fine. Now, this is one of the examples that we are taking. Let's move on to another example. Let's say I have to calculate 190 is what percentage of 820. So again, focusing on the fraction 190 by 820, I'll get 19 by 82. Now this time be careful. 10% is 8.2, double of which will be 16.4. Now, as number 19 is greater than 16.4, 19 upon 82 will come out to be greater than 20%, isn't it? So I'll start from 20%. Instead of 10%, I'll start from 20%, which is 16.4. Now, if I add up another 5%, 10% is 8.2. If I add another 5%, which will be 4.1. If I add 4.1 to 16.4, you can easily observe that the result will cross 20 and the number which you are targeting is 19. So obviously if I add another 5% and make it 25%, I'll cross the number 19. So now I've figured out that the number 19 lies between 20 and 25% of 82. I'll just repeat it. See, I found 10%, 8.2, doubled it to get 20%, that is 16.4. Now, if I add 5%, which is half of 8.2, 4.1, this will be 20 point something, which will cross 19. So, is 19 is less than 20 point something. So, this will not go up to 25%. So, the number is greater than 20%, but less than 25%. Hence, it lies between 20 and 25%. Now, what to do next? Next, I'll move on to 1%. Now, 1% is 0.82. This time we'll not write that minor calculation that we did of 1%. We'll do it in our mind. Now, 1% is 0.82. Or rather, let's take it approximately 0.8. So, I can just see that 2 point something has to be added to 16.4 to make it to 19. So, what I'll do is 0.8 thrice, that is 3 into 0.28 is 0.8 is going to give me 3%, isn't it? Because if I add 3% to it, I'll add 3 into 0.8, which will be 16.4, and this will become 2.4 over here. So can I say 20% we have easily found at 16.4. 3% will be 2.4. Now if I add them up, I'll first of all get 18.8 as the result, and this will be 23% of 82. So we have come very, very close to 19 over here again, as we did in the previous case. Now what I need to do is to just add another 0.2 to 18.8 to make it to 19. Now this time, now I'll focus on 1%, that is 0.8, 1% being 0.8. Now 1/4 of 0.8 is 0.2. Now 1/4 of 1%, 0.8 will be another 0.25 percentage, isn't it? So 0.25%, if I add another 0.25 percentage to 23, I'll have to add another 0.2 to 18.8, and hence it'll become equal to 19. So my answer over here will be 23.25, which is very, very close to our real answer, isn't it? So that is how we are going to calculate complex percentages over here. We have to be slightly comfortable with numbers. This will take some practice to observe 1%, what part of 1% is fitting over here. This will take some practice. So don't you worry about it. Again, in this section, the only lecture in which you require practice is this lecture. Fine. So we'll move on to few real-time examples in which we'll see if there's a pen and a paper in front of me, how fast would I be able to do complicated percentage. Fine. So let's move on to that.